Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 10 of lesson number 9, Force and Laws of Motion. So as you all remember that in part 9, we discussed more about conservation of momentum, and we even came up with a law on conservation of momentum, right? So that is also one of the most important part for the lesson that you should be knowing about. Okay, that is about the conservation of momentum. Apart from that part, now we are left with examples. We have many examples and activities ahead, and after that we have the summary discussion and 18 exercise questions to discuss. So as there are more examples and activities in the lesson, that we in the part that we are left with, let's see today if I would be able to complete only the examples and the activities part. But because if the questions would be less, I would have completed today itself. But as there are 18 questions altogether, let's see if it's possible. I'll do it today itself. Otherwise, I'll need one more part for the lesson where we will be just discussing the summary and the exercise question. Okay. So before I proceed with this part for the lesson, I hope every one of you have already started revising whatever we have discussed so far, because it's very important for you to know and for you to revise each and everything, because that is what is going to make you thorough and confident enough for the lesson. See, you knowing the concept and you are being confident on the lesson are two different things. If you know the lesson, it means you know only the lesson whatever has been given. But if you know the concept, you can relate it to real life examples. You can come up with so many things related to the topic. Okay, so I want you all to be confident with the topic, with whatever you are studying. Okay, so please revise each and everything that we have discussed so far in the lesson, everyone. So we have started the lesson by discussing about force in detail. I want you all to please go through it quickly. I hope every one of you are going through it. So we have discussed this much about the balanced and the unbalanced force till now, right? Then we started like till here we have everything about force, that is what are the effects of force, what are the SI unit of force, what force can actually do onto an object. Then we discussed on the two types of forces, that is balanced force and unbalanced force. And after that we started with the three laws of motion that we have, starting with the first law of motion, which is also known as law of inertia. Okay, so I just want each one of you to please go through this slide, as we have many different examples for the law of motion, which is first law of motion, which has been given over here. So please be quick with it, everyone. So here we had like more information about the inclination that has been discussed over here in the figure 9.5. So figure A, if you can see, that is showing us the downward movement of the marble ball. Then figure B is showing us the upward motion of a marble on the inclined plane, and figure C, it shows like it shows us a doubled inclined plane, right? So I want each one of you to please go through the slide and try to understand what exactly law of inertia is. Now you might be clear till now, but please, if you are clear, make sure you're going through it quickly. I hope every one of you are going through it. After this, we discussed about the Newton's idea and how Newton came up with the three laws of motion, starting with the first law, that is law of inertia, and it has been stated as well over here on the slide with different examples which have been given, right? So I want you all to please be quick with this slide as well. I hope every one of you are revising it properly. Then we had this activity 9.1. So I just want you all to please go through it as well quickly. Then we discussed on inertia and mass with the same example that we discussed over here about the seat belt, right? So same thing has been discussed over here but in detail as inertia and mass. Then we discussed on the second law of motion as well. And here we have all information about like many different examples which is related to second law and information on momentum as well. Like how can we define it? What is the formula for it? Everything about momentum has been explained because second law of motion is mostly been concerned with momentum, right? So I just want each one of you to please go through it. Sorry. Then over here we have more information on momentum that has been given. I just want you all to please go through it as well. Sorry. I hope you all are going through it. Like this slide is again very important because here you have the second law that has been stated at the end, that it is rate of change of momentum of an object is proportional to applied unbalanced force in the direction of force. Okay. Then we discussed on the mathematical formulation of the second law of motion, like how can we come up with the mathematical formulation of momentum, right? So I just want you all to please go through it. I hope you all are going through it. I hope you all are going through it. So here we have the we have derived the formula for force, that is equal to mass into acceleration. Then we had example 9.1 of how we can calculate the final velocity of the object. Now you have seen the exercise question. I always show you all the exercise questions at the end of the part, right? So you might be aware that you are going to tackle with this type of questions where you will be told to find out the final velocity, the initial velocity or the velocity itself, then the acceleration, then you will be even asked to find out force, right? So you should be aware of how to do it, and that is the reason we have these examples which have been given. So I just want you all to please go thoroughly through this so that it will help you further solving the exercise questions as well. Okay. After this, like here we have found out or calculated the force, right? So just go through this as well, everyone. So over here, like in the third example, we discussed on the, like we calculated the force exerted by the brakes on the bike, motorbike, right? So I just want you all to please go through this as well. I hope every one of you are going through it. See, you need to know the trick and the formulas. Like once you know all the formulas, it will become easier for you to understand and know this. Okay? Then we discussed on the third law of motion. So I want each one of you to please go through it as well. So this is the real life example like which has been given. Then we had this example 9.4. So I just want you all to please go through this example as well. Then we discussed about conservation of momentum. So I want you all to please go through it as well. Sorry. Now we have this activity 9.5 to discuss. See, what you need to do is take a big rubber balloon and inflate it fully. Tie its neck using a thread. What will you do? You are going to tie the neck of the balloon using a thread, and also using adhesive tape. Fix a straw on the surface of this balloon, and then after doing all this thing, pass a thread through the straw and hold one end of the thread in your hand or fix it on the wall. So you have to like pass the thread through the straw as shown in the figure. Okay. Then ask your friend to hold the other end of the thread or fix it on a wall at some distance. And when you do all the when you follow the protocol, you'll come to know like your arrangement will look the same as you can see the figure 9.15. Okay. Now what you need to do is remove the thread that you have tied on the neck of the balloon and let the air escape from the mouth of the balloon. So as you can see in the figure 9.15, they have shown how the air is escaping out of the balloons, right? So observe the direction in which the straw moves. Now when you do this activity, the air is moving out of the balloon, and you will see that the straw will, like, you have to check in what direction the straw is going to move in that case. Okay, so your observation over here, like as you can see the arrow which has been marked, the straw along with the balloon is going to move opposite in the direction in which the air escapes. So if the air is escaping in the right, the straw will move to the left. So it's always going to be opposite in opposite direction in which the straw is going to move. Okay, now why is it so? Why the straw is moving in the opposite direction? It's because of the phenomenon, okay, known as Newton's third law of motion. Why is it so? It's because of Newton's third law of motion. And when the thread is removed, when we remove the thread, the air escapes due to the reaction. The balloon with straw will move in the opposite direction, and this is because of the third law of motion. We know that there is always an equal and opposite reaction to an action, right? What, like, what is always there? There's always an equal and opposite reaction to an action. This is the third law that we are aware of, right? Now apart from this, like if you have to come up with other examples of third law, is like we already have discussed that when a boatman pushes the river bank with a pole, the river bank offers an equal and opposite reaction in that case as well, right? So this reaction is going to help the boat to move ahead. What will happen? This reaction is going to help the boat to move ahead, and when the gun recoils, there's an equal and opposite force that is exerted on the gun, right? So the gun will move backward in this case again. And one more example that you can have is motion of rocket and jet aeroplanes, right? So at the end, what conclusion you can give for this activity is that this activity demonstrates the third law of motion. What does it demonstrate? It demonstrates third law of motion. Okay. I hope you all are writing it. After this, like, see, we have activity 9.6 as well. What we need to do over here is take a test tube of good quality glass material and put a small amount of water in it. Then place a stopcock at the mouth of it and suspend the tube horizontally by two strings or wires as shown in the figure. Okay. Then heat the test tube with a burner until water vaporizes and the cork blows out, and observe that the test tube recoils in the direction opposite to the direction of the cork. And also observe the difference in velocity the cork appears to have and that of the recoiling test tube. Now you won't be doing the activity, your teacher can demonstrate this in the lab, but you won't be allowed to do this because like Bunsen burner has been involved, and also like the test tube needs to be broken down over here, so like you won't be doing the experiment. Okay, you're just going to observe, and when you observe the experiment you will see like what observation you can come up is when cork blows the test tube moves in the opposite direction. What will happen whenever the cork will blow, the test tube will start moving in the opposite direction. Okay, then what explanation is that you can give out over here? Like, let's say if the question is why cork blows out, so you can write that when we hit the test tube, water in it expands and changes into vapor, and the vapor in that case will have higher volume and it will start exerting pressure on the cork. What will happen? Vapors have higher volume and they start exerting pressure on the cork, and as a result a time comes when the cork will blow out. So now the next question that you can have is like why does the test tube recoils? Because here they have told you to observe the recoiling of the test tube, but the question is why the test tube will recoil. So recoiling of the test tube is like similar to recoiling of the gun, like we have discussed that for the third law, right? So recoiling of test tube is the same as recoiling of the gun after firing or moving of cart, that we discussed already in 9.4, right? So here the movement of the cork is going to create an equal and opposite reaction as per Newton's third law of motion, because we know that as per second law F is equal to ma, force is equal to mass into acceleration, right? So we can write that mass of cork into acceleration of the cork is equal to mass of test tube into acceleration of the test tube, right? We can come up with that. So I just want you all to write the observation and explanation that I just now like described about this activity 9.6. I hope every one of you are writing the observation and conclusion. Now I'll start with the examples in the next class. Okay, but make sure that you go through all the examples that have been given over here, like 3 examples we are left with. Okay, and then we have the summary that we will be discussing at the end. So we'll be doing that later. And just go through the exercise questions quickly, everyone. So altogether we have 18 questions that we will be discussing at the end of the lesson, and we will be doing that in the next part itself. So this is how we will be ending up with the lesson force and laws of motion. And I hope whatever we have discussed till now in this part, you're very much clear with it. Now rest of the part I will be continuing in the next class. Thank you everyone.